is a bird. So we can rewrite our statement of all ducks are birds into something that's a little bit more technical. That is, we could go back and say that for any individual thing x, if duck x is a duck, then x is a bird. So this is what in formal logic we tend to call logicese. And this is how you spell that. Logicese. Logicese. In logicese, we would translate if x is a duck, then x is a bird, to say that for any individual thing x, if x is a duck, then x is a bird. With symbols, what we have to end up writing is that for all x, because remember we're talking about all things, if x is a duck, then x is a bird. Note that the universal affirmative statement here involves an arrow. The universal affirmative statements will almost always involve an arrow. Let me rephrase that again. Universally affirmative statements will almost always involve an arrow. If you're not using an arrow, then something has plausibly gone wrong. In fact, if you were to try to write this, you can probably see why it would be wrong. This statement here says for all of x, if x is a duck, then it is a bird. This statement, however, says for all of x, everything is both a duck and a bird. In other words, there's nothing in the world at all or the universe that is not both a duck and a bird. That's not the same as this. So for universals, just more or less memorize it. You're going to be using an arrow. So there's a number of ways to represent universally affirmative statements. We could say that every duck is a bird, each duck is a bird, ducks are birds, any duck is a bird. If anything is a duck, then it is a bird. Anything that is a duck is a bird. A thing is a duck only if it is a bird, or even that only birds are ducks. All of these would be symbolized in this manner. So this is the universally affirmative statement. Let's go on and take a look at the universally negative statement, also known as a UN. Now note that the language I'm using here is not the language necessarily that Lemon uses. It's actually the same exact format, but it's just slightly different. So let's say that we had a statement of the following. Let's say that we had no ducks or reptiles, where dx stands for x is a duck, and rx stands for x is a reptile. This says, in effect, that if anything is a duck, then it is not a reptile. In logicese, we could translate this as for any x, if x is a duck, then it is not a reptile. So we're going to be able to symbolize this statement by using the universal quantifier and the tilde and the arrow, but also adding a tilde. So we start with the universal quantifier for all of x. If x is a duck, then it follows that that thing is not a reptile. Much like there are various ways to represent a universally affirmative statement in English, there's a number of ways to express a universal negative in English. For example, we could say that nothing that is a duck is a reptile. All ducks are non-reptiles. If anything is a duck, then it is not a reptile. A thing is a duck only if it is not a reptile. Nothing is a duck unless it is not a reptile. All of these things would be translated like this. And note, we are still using the arrow. So the tilde placement is sometimes where folks get a little bit lost, but I would say always focus on kind of what's being said. So for example, let's say that we had, let's look at a few more sentences and kind of parse them out. Let's say that we had the sense that nothing is human, that not everything is human, and that not every human is a hero. And let's use hx to represent being human. And for hero, let's just use a mx, just because we can't use h again. So if we said that nothing is a human, then one way of symbolizing this would be to write, for all of x, it's not the case that that x is human. If we wanted to write that not everything was human, we would write instead that it is not the case for all of x that x is human. Notice that these two things are saying different things. The first one says that for all of x, it is not human, so there are no humans at all. The second one is saying that it's not the case that everything is human. There still could be some humans, but it's just that there also could be some non-human things. And then if we wanted to say that not every human is a hero, then we would say that it is not the case for all of x that if x is human, then x is a hero. This leaves it open to there being some humans that are heroes, but it clarifies that not all of them might be. So what we've done so far, we've done the universal affirmative and we've done the universal negative. So let's go ahead and continue on using our logic keys language, and let's take a look at the existential quantifier. The existential quantifier looks like this. We can just kind of translate this into logic keys as there exists an x such that. Notice that this is in contrast to what I said for the universal x, which I translated as for all of x, it is the case that. So slightly different translations here. So this is the second type of quantifier. It's called an existential quantifier, and it's used to assert that at least one thing has some specific property. Our symbol for the existential quantifier looks like this. The backwards facing E and the little x. The E is backwards so it won't be confused with a predicate letter. And this symbol can be read either there exists an x such that, or there is at least one x such that, or even there's an x such that. More or less pick the way that you want it to read. So let's take a look at a quick example. Something is round. And let's use Rx to represent x is round. It's part of the round category. In logic keys, what we would say for this sentence is there exists an x such that x is round. In other words, there exists an x such that x is part of the round category. With the existential quantifier in hand, we can also symbolize what we can call particular affirmatives. Notice earlier what we did is we looked at universal affirmatives. Universal affirmatives were things about everything. In contrast, particular affirmatives are things about some specific thing. So let's consider this sentence. Some birds are ducks. Let's have bx again be x is a bird, and let's have dx again be x is a duck. Some means at least one. So in logic keys, our statement looks like this. There is at least one x such that x is both a duck or both a bird and a duck. Let me write that out. So if we were to translate this into what we call logic keys, we would say There exists an X such that it is both a bird and a duck. Now, why did we have to translate it with an and statement here? Well, when we look up here, we see that we have two different categories. We have two different categories, two different groups that X's could belong to. So when we're telling somebody that something belongs to two of those categories, we need to and those categories together. We need to tell them explicitly that they are part of both of those categories at the same time. So we would write it out as this way. We would write there exists an X such that X is both a bird and X is a duck. Some in this case means at least one. It doesn't mean everything, however. So this is not the same as writing there exists an X such that if it is a bird, then it is a duck. Why? Well, one, this statement is true, while this statement is false. So the truth values being different should give us a flag that something has gone wrong here. So I would say the thing to note here is the existential is paired with an ampersand. Much like the universal is usually paired, if not always paired, with an arrow, an existential quantifier is going to almost always be paired with an ampersand. So let's consider some alternative ways of translating the sentence. Other ways that you could see the sentence are at least one bird is a duck, there are birds that are ducks, something is both a bird and a duck, and there exists a bird that is a duck. Each of these things would be symbolized using this method. Since we just looked at a particular affirmative, let's look at a particular negative. Some birds are not ducks. And we're using dx and bx again. Let me switch those around just for clarity. Let's talk about birds, ducks, and remember we have two categories here. In logic ease, we would translate this statement as there exists an X such that X is a bird and not a duck. Let's say that one more time. There exists an X such that X is a bird and X is not a duck. There are a number of other ways of translating this type of sentence. We could say that there is at least one bird that is not a duck. There are birds that are not ducks. Something is a bird but not a duck. Not all birds are ducks, or not every bird is a duck. In each case, this could be translated as the following. We could also translate it using a universal, though. We could say that it is not the case for all of X that if X is a bird, then it'll be a duck. These are logically equivalent statements. And later on, we're going to be able to kind of point to why they are logically equivalent. But for now, it'll be enough for you to know that these are logically equivalent statements. So what I've tried to do here is symbolize a number of ways to translate four different common predicate logic statements that you're going to be seeing. These are, I would say, the foundation for understanding all the rest of the predicate logic that we're trying to do, all the rest of the quantifiers that we're trying to do. But let me run through just a few more examples of things that you could end up seeing, and I'm going to show you both the standard translation, the logic ease translation, and also how to symbolize it. So this is going to take a little while, but this is for folks that aren't quite comfortable yet doing certain types of things. Before I do that, though, I would say, let me just quickly flag one thing. Notice that in each of these cases, we have parentheses that are binding the variables. We say it binds because X goes over everything in the parentheses. If you had something that looked like this, EX, BX, and not DX, the EX would be limited just to the BX. So always be mindful of your parentheses and where they're placed. and also try to be very intentional when you're approaching these things to make sure that you're not forgetting parentheses. That said, since we have a